We still can't find the source of the mysterious signal we've been receiving since 2018. We receive it every 22 minutes and nothing can explain this. Some scientists even believe it could be coming from another civilization we haven't met yet. This strange radio signal wasn't found by a scientist on a serious mission. It was actually discovered by a college student just doing a regular project for school. Tyrone O'Doherty, an undergrad student at Curtin University in Australia, was sifting through old data of the southern sky. He was looking for any weird blinking radio signals. He finally stumbled upon one from 2018 that seemed to shoot radio waves towards Earth like a lighthouse beam. Excited about his find, Tyrone shared it with his mentor, radio astronomer Natasha Hurley-Walker. She dove into researching this signal, hoping for a breakthrough. But despite checking different frequency data, they hit a dead end. But then, Natasha spotted a pattern. The signal repeated every 18 minutes. This was huge. But just as they were gearing up to study it further, poof! The signal vanished after only 3 months, leaving them with nothing. Not giving up, Natasha and her team scanned the skies again, desperate for a clue. Months passed, but nothing turned up. They were ready to give up, and then suddenly, a new signal popped up. This one kept blinking for 5 minutes, then it disappeared. And then it came back exactly 22 minutes later. The main question was if that signal was related to an 18-minute one. To figure it out, Natasha went back to the old radio data from that area. As they dug deeper, they realized that, yes, and these signals aren't anything new. They'd been beaming towards Earth for 35 years. Back in 1988, Indian and American telescopes had caught them, but they got buried under tons of other data. This was great news for space explorers because it meant they could now calculate how far away this mysterious object was. After doing the math, they figured out it was incredibly far, even on a space scale, 15,000 light-years from Earth. Now, the only thing left to uncover was what exactly this object was. Walker and his team started comparing it to all the known radio-emitting objects out there. Yet its source remains a mystery. The signals still pop up every 22 minutes on NASA screens, always ending with a frustrating match not found message. The scientists called it J183910. Some think that the signal might come from some extraterrestrial beings. Maybe it's the signal that SETI, the search for extraterrestrial intelligence, has been waiting for. This project has been working for over 50 years, trying to find any evidence of life beyond Earth. They also scan the skies for radio waves, laser pulses, and other mysterious signals. So maybe it's a way for extraterrestrial folk to communicate their location. While that idea may sound exciting, we need to be careful about jumping to conclusions. First, we don't have solid proof for that. Before any concrete evidence, it's just speculation. And also, there are other more plausible explanations. Most likely it comes from a natural phenomenon, and there are a couple of theories for that. The first one is the pulsar theory. Imagine a huge star in space much bigger than our Sun. Sometimes these big stars finish their life journeys in a spectacular event called a supernova. When this happens, the star's core collapses, becoming super compact, as if you're squeezing all the stuff from that star into a tiny space. That tiny, super-dense core is called a neutron star. Some of these neutron stars are extra special. We call them pulsars. They get their name because they seem to pulse with energy, like a space lighthouse. These pulsars have incredibly strong magnetic fields, much stronger than what you'd find on Earth. They're like enormous magnets in space. Because of this, they shoot out beams of energy. They're also spinning super fast, so these beams of energy seem to pulse on and off as they spin around. Now, the strange signal we detected seems to have similarities with pulsars, but not quite. Pulsars usually have a predictable lifespan and slow down over time, eventually stopping their radio signals. In contrast, our mysterious signal is quite persistent and is blinking beyond what's expected for pulsars. So, maybe it's not a typical pulsar, or not a pulsar at all. There's also a magnetar theory. Now, a magnetar is another type of neutron star. They're like supercharged versions of pulsars, with even stronger magnetic fields and slightly longer pulsating periods. Maybe this is what causes our signal's intense persistence. However, when we plotted the data, we also realized the signal didn't match the magnetar's vibes either. Magnetars not only send out radio waves, but also powerful X-rays because they're so energetic. But the signal we received was only sending out radio waves. So we figured it's not a pulsar and not a magnetar. The signal's behavior is very strange and suggests an unnatural source. This means there might be something in the universe that scientists haven't fully explored yet. And there is a space object that we don't know much about. The final theory is the so-called dwarf pulsar. Sounds a little dopey to me. Couldn't help myself. Now, a dwarf pulsar is like a star that blinks with light flashes, similar to pulsars, but it takes longer for each blink. Usually, white dwarfs are the leftovers from smaller stars. They don't blink because their magnetic field isn't as strong as pulsars. But when a white dwarf becomes pretty hefty, almost the mass of our Sun, it gets super dense and starts pulsating with a strong magnetic field, just like pulsars. They have a cool quirk. White dwarfs are made of electrons, not neutrons like pulsars. When these charged electrons start dancing with a magnetic field, they shoot out periodic light flashes, which happen every 100 to 1,000 seconds. As you remember, our signal has a period of 22 minutes, 1,320 seconds. A bit longer than the usual white dwarf pulsars, but it's much closer to the truth. So far, this sounds like the most plausible explanation. But even this theory isn't fully confirmed yet. This just shows how much there is in the universe that we're still figuring out. For example, fast radio bursts, another mysterious type of signal we've been detecting. They're like quick, intense bursts of energy in the form of radio waves. They have a ton of energy. FRBs are so powerful that sometimes they can be brighter than entire galaxies. Now, imagine this. They release as much energy in a few milliseconds as our Sun does in 3 whole days. Wow! These bursts happen all over the sky with huge frequencies, although some have been detected with lower frequencies. Every day, we catch around 10,000 random FRBs in the sky. Some of them repeat, but most happen once and disappear forever. Unfortunately, most of them only last for a fraction of a second, and by the time their energy reaches us, it's 1,000 times weaker than a mobile phone signal from the moon. This is why, despite their brightness, there's still a lot we don't understand about them. We're still trying to figure out what causes these FRBs. They could be coming from different sources, like already mentioned magnetars, colliding stars, or even merging galaxies or white dwarfs. As these bursts travel through space, they pick up information about the cosmic environments they pass through, like interstellar gas clouds. It's very unlikely that FRBs are some messages from extraterrestrial beings, though. Not only because there are thousands of them every day all across the sky, but also because we know that the sources of these bursts must be incredibly energetic themselves. Our neighbors would have to have equipment stronger than entire galaxies for that. But the bottom line is, while all these signals are fascinating, there's still a ton to learn about them. Okay, I officially give up on the hope that the moon is made of cheese after all. Wow, not even Gouda. The shiny lunar ball, or a curved banana, or half of a coin, depending on what phase it's in, has different layers inside, just like Earth. One of these layers is called the inner core. About 20 years ago, scientists were observing how the moon rotates. Using that data, they concluded that it had a fluid outer core. But the inner core was hard to study, so they didn't know if it was solid like a rock or molten like a hot liquid. But things are clearer now. Astronomers have collected data from different missions, including the Apollo missions, where astronauts went to the moon and gathered information themselves. Plus, they've used a special technique called seismic data. This method is all about studying how sound waves move through things. Take earthquakes on our planet as an example. When an earthquake happens, it creates waves that travel through the ground. Scientists can detect and analyze these waves to learn more about Earth's interior. The same idea can apply to other objects in our solar system, or planets, or, in this case, the moon. When quakes or moonquakes happen, they generate sound waves, and by carefully listening to and studying these waves, scientists can create a detailed map of what's inside the object. They can figure out things like different layers, what they're made of, and how they're arranged. To check the moon's deep interior, scientists also use something called laser ranging. This method measures the distance between the surface of the Earth and the moon very precisely. And ta-da! Our natural satellite's inner core is a dense, solid ball made of iron, just like Earth's. It's about 310 miles wide, which is nearly 15% the size of the entire moon. Researchers also have stumbled upon evidence that supports the theory that the layer between the moon's surface and its core, called the mantle, has been moving around as the moon evolved over time. This movement is something we call lunar mantle overturn, and it could explain why we find elements rich in iron on the lunar surface. Mantle material ends up being carried upward, and the volcanic rock remains in the moon's crust. Some of the materials in this rock were too dense, like me, so they just sank back through the lighter crust material all the way to the core mantle boundary. It's like a cycle where the moon's mantle material goes up during volcanic activity, carries iron-rich elements to the surface, and then sinks back down. There's another mystery scientists have been trying to solve: what caused the moon's magnetic field to weaken and nearly disappear over time? It seems that now that we know about the iron core and the global mantle overturn, we might get some more answers about the moon's magnetic field. Knowing what the inner core is like can help us better understand the moon's history as well as the history of our entire solar system. Now, one of the theories that's widely accepted about the origin of the moon says there was a massive collision between Earth in its early stages and another mysterious object in our solar system. It's called the Large Impact Theory, and this collision was so strong it ripped off a big chunk of the primitive molten Earth. I mean, not so big compared to what's left. If you put a US nickel next to a green pea, you get a good idea of how big our planet is compared to the moon. Now, this chunk was set into orbit around our planet, and this might have happened about 95 million years after our solar system formed. The object that collided with Earth could have been about 10% the mass of our home planet and roughly the size of Mars. Well, it makes sense. Earth and the Moon do have similar compositions after all. Of course, there are other ideas about how the Moon formed. One says that the gravitational force of our planet captured it. This means that the Moon was just an object innocently passing by when suddenly it got attracted and pulled into Earth's orbit. There's even a hypothesis that Earth stole the Moon from Venus. Ooh. In that case, the Moon shouldn't complain. I guess the view is way better here. So yeah, the Moon and Earth are similar when it comes to rocks and some minerals. But the Moon doesn't have the same atmosphere as our planet. Its atmosphere is thin and consists of some weird gases that include potassium and sodium, which is not something you can find in the atmosphere of Mars, Venus, or Earth. And the rocks on the Moon don't contain water. But that doesn't mean there's no water at all up there. A long time ago, in the 17th century, astronomers saw large dark spots on the Moon's surface. One of these astronomers thought these spots looked like oceans, and he called them maria, which means seas in Latin. Other astronomers also made maps of the Moon, and they used the term maria to describe these dark spots. For example, Mare Tranquillitatis translates to Sea of Tranquility, where Apollo 11 made its touchdown. But it seems those dark spots are not actually oceans. They are plains made of hardened lava that erupted long ago. These volcanic eruptions left behind smooth flat areas called basalt plains. In the late 1800s, one sky watcher studied the moon and found it didn't have an atmosphere. Without an atmosphere, there are no clouds and no air to keep water from evaporating. So scientists thought that any water on the moon would just disappear right away. They believed the moon was totally dry. But then, in 1961, one physicist had a different idea. He pointed out there could be water on the moon in special areas called permanently shadowed regions. These are spots on the moon where the sun doesn't shine, so they stay dark all the time. Water ice could exist in these dark areas because they're extremely cold and the ice wouldn't evaporate. But when astronauts from the Apollo missions went to the moon, they brought back soil samples, and scientists found no signs of water in them. So everyone went back to thinking that the moon was completely dry. In the 90s, NASA focused on these shadowed craters and found high concentrations of hydrogen, which meant there could be ice at the moon's poles. They still weren't certain, so they kept digging and, after a while, found hydrogen trapped inside tiny beads of volcanic glass. Since there are no active volcanoes on the moon today, which means water probably was present on the moon when these volcanoes erupted long ago. Plus, there could be way more water back in the early days of our moon. In 2020, NASA's SOFIA mission showed us what we'd been looking for a really long time. There is water on the moon after all. It turns out the water is hidden within the grains of lunar dust or sticking to the surface in the sunlit areas of the moon. So there are no oceans like we have on Earth, but at least there's something. The question remains, how did water even get there? It seems the moon had a chaotic history back at the time when it was forming, as probably most of the planets and moons in our solar system. So there is some evidence that water came there from comets hitting its surface back in the old days, or maybe even keeps on coming from those that are slamming into the moon right now. We're talking about a chaotic situation where icy micrometeorites collide with the moon's surface, and dust then makes an even bigger mess when interacting with the solar wind. But we're waiting to find out more about this. Because, as we all know, when you mention water, you also inevitably talk about life. That's why we want to know more, for instance, about all that ice hidden in polar craters on the moon. Maybe it can teach us more about how life developed on Earth. Maybe comets brought all the necessary elements here. Then, what if there are some of those elements stuck in the ice on the moon, too?
Throughout the years, scientists have made some discoveries that seem to hint at the existence of extraterrestrial life. But do they really? Let's find out. In 1976, NASA's Viking Mars landers detected chemical signatures that could be a sign of extraterrestrial life. During one of the experiments, Martian soil was mixed with special nutrients and then tested for the production of methane gas, and the test's result was positive. In other words, something in the soil was metabolizing these nutrients and producing the gas. Unfortunately, other experiments conducted on board the landers didn't show any evidence of life. It caused NASA to declare the result a false positive. And still, some scientists keep standing by the finding, arguing that the experiments on board were ill-equipped to look for a key indicator of life, organic molecules. In 1977, an Ohio State University radio telescope detected a bizarre pulse of radiation coming from someplace near the Sagittarius constellation. It lasted 37 seconds and was so unexpected that the astronomer who was monitoring the data at that moment scribbled, "Wow," on the telescope's printout. The thing is that the radio frequency of the signal is internationally banned on Earth. The signal could be the result of a supermassive astronomical event, or it could be sent by some kind of intelligent life with immensely powerful transmitters. So far, this mystery has remained unexplained. In 1996, NASA scientists announced that they had found something that could be microbes in a potato-shaped chunk of Martian rock. The meteorite might have been blasted off the surface of Mars in a collision. It had been wandering the solar system for about 15 million years before it fell in Antarctica. Analyses showed that the meteorite contained some organic molecules and tiny particles of the mineral called magnetite. It's sometimes found in bacteria living on our planet. NASA researchers used an electron microscope and announced that they had spotted nanobacteria. But since that time, this evidence has been called into question a few times. Some experts say that the particles of magnitude are not really similar to those found on our planet, and Earth's contaminants are likely to be the source of organic molecules. Jupiter's moon Europa has a bizarre red tinge. Some of the theories explaining this phenomenon have suggested the reason is frozen bits of bacteria, which are also responsible for the mysterious infrared signal the moon gives off. But this theory hasn't been proven yet. The existence of life in Venus's clouds might explain curious anomalies in the composition of the planet's atmosphere. Solar radiation and lightning are supposed to generate tons of carbon monoxide on Venus, but in reality, this gas is rare, as if something is removing it. Another weird thing is the presence of both hydrogen sulfide and sulfur dioxide in the atmosphere. Usually, these two readily react together. That's why it's rare to find them coexisting. The only explanation can be that some process keeps churning them out. But probably the most mysterious is the presence of carbonyl sulfide. The thing is, on Earth, it's only produced by microbes and not by some inorganic process. Some experts believe that microbes might be living in the atmosphere of Venus. The surface of the planet, scorching hot and acidic, isn't very suitable for the development of life, but up in the atmosphere it's moist and hospitable, with a pressure similar to Earth and pleasant temperatures. But again, we haven't received any solid proof yet. In 2003, scientists discussed the possibility that the traces of sulfur on Jupiter's moon Europa could be the waste products of colonies of underground bacteria. The compounds were first discovered by the Galileo space probe, which also found some evidence of a volcanically warmed ocean beneath the icy crust of the moon. The sulfur signatures look similar to the waste products of bacteria living in the surface ice covering lakes in Antarctica on Earth. But other scientists rejected the idea. They argued that the sulfur could have come from the neighboring moon. Io there, it's found in abundance.
Now, think about the vastness of the universe. Our galaxy contains between 100 and 400 billion stars. Many of them can potentially host planets. Many of those planets might have water in them and be capable of supporting life. And this is just the Milky Way alone. What's the likelihood of other intelligent civilizations existing out there? Well, there's a famous formula called the Drake equation. It's a mathematical tool to guess how many civilizations from outer space might be able to talk to us in our Milky Way galaxy. It was made by a scientist named Frank Drake in 1961. Here are the variables in it. N is the number of civilizations we could potentially talk to in our galaxy. R star is how fast new stars are born in our galaxy. F sub p is the fraction of stars with planets around them. N sub e is the average number of planets around each star that could support life. F sub L is the fraction of those planets where life might actually start. F sub I is the fraction of planets with life that could become smart civilizations. F sub c is the fraction of smart civilizations that send signals into space. And L is how long those civilizations keep sending signals. Of course, we won't get an exact number like this. It's more like an educated guess, and we don't have any answer to that. But based on at least some information we know, there might be around 100 million worlds where life should have evolved. But if that's the case, then why haven't we met or heard from anyone? This is called the Fermi Paradox. It's named after the famous physicist Enrico Fermi. He asked a simple but very important question: where is everybody? Our universe should be filled with chatty extraterrestrial beings, advanced civilizations, and spaceships zipping around. Yet, when we look up at the night sky or listen with our radio telescopes and antennas, it's eerily quiet. All we get is the so-called Great Silence of the universe. Scientists from Oxford University's Future of Humanity Institute are trying to answer this question. And they're not the only ones. A group called METI, for Messaging Extraterrestrial Intelligence, organized a workshop in Paris in 2019 to explore this mystery. The workshop brought together experts from various fields, like astrophysics, biology, psychology, and so on. One of the ideas discussed is called the zoo hypothesis. It suggests that perhaps other civilizations do exist, but they're simply not broadcasting their presence. Maybe they know that making direct contact with us could be risky for both sides, so they're intentionally avoiding us because they're watching us like observing a zoo. They could be using advanced technology we can't detect. There are also some optimistic explanations, like time delays. Space, as you know, is unimaginably big. The time it takes for signals or information to travel across the universe is enormous. It's possible that other civilizations exist, but their signals haven't reached us yet, or ours haven't reached them. But some explanations aren't very optimistic. Like, some scientists think Earth might really be unique. Maybe the conditions that led to life and intelligent beings are so incredibly rare that there are no other planets like ours. Scientists point out that there are many planets similar to Earth, and some are much older. This means there should be plenty of planets where life could evolve. Recent research also suggests that life might be way more resilient than we thought. And, well, while it increases the amount of life existing out there, it also increases the chances that intelligent life doesn't last very long. It might destroy itself before it can spread to other parts of the universe. This is a concerning idea for the future of humanity. The researchers also considered that many planets might be at a similar stage in their development. That's why it's hard for them to explore the universe at the same time. But even they agreed that this explanation is way too far-fetched. And finally, one of the big potential explanations is called the Great Filter. This idea was suggested in the 1990s by Robin Hanson. It says that for life to develop and become advanced like us, it has to overcome some really tough challenges. First of all, the planet itself should have a good stable star and good enough conditions on it. Then life has to start on that planet. These life forms need to be able to reproduce using things like DNA. Simple cells must evolve into more complex cells. More complex organisms with multiple cells must develop. And eventually, these organisms must figure out how to reproduce, which increases genetic diversity. And finally, these organisms must be smart enough to use tools, create, and explore things. Finally, they should colonize other planets and star systems without destroying themselves. And maybe one of these stages is so incredibly hard that most civilizations don't make it past that point. This challenge could be something like developing intelligence in the first place, or it might be the struggle to avoid self-destruction. So, perhaps life isn't rare at all, but most of it doesn't go beyond simple tiny organisms like bacteria. Even if the universe is full of bacteria, they don't become advanced enough to build spaceships. The Great Filter might also be something from outside, like a huge asteroid crashing into a planet, a dangerous burst of gamma rays, or a massive star going supernova. These events could destroy life on any planet, no matter how advanced they are. So, if we've already passed this challenge, it means we could be the only ones in the universe and we can explore it. But if we suddenly hear from a super advanced civilization, it could mean the hard part of the challenge is still ahead of us. Now, the Fermi Paradox focuses on intelligent civilizations. It just implies that there should be civilizations more advanced than us, or at least as intelligent as us. But if you think about it, why should extraterrestrial life be similar to ours at all? It might be completely different for many important reasons. Life elsewhere might have developed under completely unique conditions. This could lead to forms of intelligence and consciousness very unlike our own. For example, it could have evolved into highly advanced forms that aren't based on biology as we know it. These beings could exist as energy-based entities, silicon-based life forms, or even as a hive mind. And because they have evolved completely differently, they may be capable of things that we aren't capable of. For example, we can't see the entire light spectrum. Our eyes also can't perceive cool things like dark matter. But who knows what the vision of extraterrestrial beings may be capable of? Their abilities might even extend beyond our three-dimensional perception. They might be able to perceive and interact with higher dimensions, which is why they could have unique, interesting insights into the nature of our world. Or maybe they've learned to think outside of time, like in the movie Arrival. For us, we still haven't met them, but for extraterrestrial beings themselves, the concept of time doesn't exist at all. They're simultaneously in the past, present, and future. For humans, something like this is hard to even imagine. Plus, even on Earth, we don't fully grasp how consciousness works or why it exists. We're not even sure when exactly we became conscious. So even if we do encounter extraterrestrial life, it will be hard for us to understand them or communicate with them. We think that they might have entirely different language systems, symbols, and so on, but they might not even have any communication systems at all. As you can see, the possibilities are endless. Evolution is a process that can go in many different directions. It's possible that extraterrestrial life developed in ways we can't easily understand or even imagine. These things are intriguing to think about. There are still no easy answers. The Fermi Paradox remains one of the most exciting and mystery questions in science. Scientists continue to explore these mysteries through a multidisciplinary approach. They're hoping to find clues that could lead to breakthroughs in our understanding of alien intelligence. And until we find a definitive answer, we can keep sparking our curiosity and imagination.
For centuries, people believed that all swans were white because that was all they had ever seen. They thought it was a universal truth. Then one day, someone discovered a black swan. It was a surprising and unexpected event because it went against what everyone believed. So yeah, the theory is named after this idea of a rare and unpredictable event that goes against our assumptions and expectations. It isn't related to the Darren Aronofsky movie. You know, the one starring Natalie Portman as a committed dancer? Nassim Nicholas Taleb is the person who named this theory. He suggested that these types of super rare and unexpected events are impossible to predict, but they can have a massive impact on individuals, businesses, and societies. The theory was originally used to explain financial markets, but has found its way into various fields. Taleb calls those extremely rare events black swans. Now, these events are so rare that the usual tools of probability and prediction, like the normal distribution, don't really work. They rely on large populations and past data, which we don't have for rare events. So, trying to use statistics based on the past won't help us predict black swans. Let's dive into some examples of past black swan events. The rise of the internet is actually a great example. It's now hard to imagine a time when people couldn't Google their burning questions or watch funny cat videos online. The internet's growth and impact caught many by surprise. It transformed the way we communicate, access information, and even buy fluffy socks without leaving the couch. A digital revolution nobody truly saw coming. Recently, we found an infant black swan on the internet: the emergence of cryptocurrencies. Bitcoin and other cryptocurrencies created new forms of decentralized digital currency and disrupted traditional financial systems. Then we have the invention of smartphones. Picture a world where phones were chunky, had buttons, and only made calls. Suddenly, boom! Smartphones turned everyone into walking wizards with tiny devices in their pockets. From taking selfies to driving with GPS, these pocket-sized marvels changed the game, surprising us all with their incredible capabilities. Here we can also mention the rise of social media. The emergence of platforms like Instagram revolutionized communication, enabling people to connect and share information globally. The creation of the internal combustion engine was a game changer too. Long ago, horses trotted along the streets, leaving a different kind of horsepower behind. But then, ta-da! The internal combustion engine roared to life, propelling cars and transforming transportation forever. Who would have thought that a mechanical contraption could replace our equine friends and pave the way for road trips and drive-thrus? What about black swans related to our bodies, like decoding DNA? Once upon a time, DNA was a mysterious code, like a secret language of life itself. Then, science unraveled its secrets, revealing the blueprint that makes us who we are. This groundbreaking discovery in genetics opened doors to medical advancements and personalized medicine. Imagine you're a scientist working in a lab. One day, you forget to clean up your petri dishes. You know, those plastic or glass things commonly used for growing microorganisms. Then, you leave for a vacation. When you return, you find a happy accident. A mold called penicillin has grown on one of the dishes and exterminated the bacteria around it. That's what happened to Alexander Fleming. This accidental encounter with mold led to the discovery of penicillin. Hello, one of the most important medications in history. At the time, bacterial infections were a major threat to human health. Fleming's chance observation opened the door to a whole new way of fighting infections and revolutionized medicine. Now let's take a peek at Europe in the 14th to 17th centuries. It was like a scene from a historical movie. People are emerging from the Dark Ages, embracing newfound knowledge and experiencing an explosion of creativity. This period is none other than the Renaissance. It's a black swan too, because during that time, there was a tremendous surge in artistic, scientific, and philosophical achievements. Incredible minds like Leonardo da Vinci, Michelangelo, and Galileo were pushing the boundaries of human knowledge. The Renaissance was like a giant wake-up call for Europe, shaking off the cobwebs of the past and embracing a new way of thinking. It was a black swan event because it changed the course of history and ushered in a period of immense progress and innovation. It reminds us that sometimes, out of the blue, a wave of inspiration and brilliance can transform the world. Let's take a step back, or 1,000 steps further, and consider the moon landing. The Apollo 11 moon landing in 1969 was an extraordinary feat of human achievement and a positive black swan event. It showed humanity's potential for exploration and scientific advancement, inspiring generations and pushing the boundaries of what was deemed possible. Not all black swans are good and positive, though. When it comes to the stock market, a black swan event is like a super rare market crash that goes way beyond what anyone could expect. We're talking about events that statistically should hardly ever happen. The Great Depression is a classic example of a black swan event. It happened in 1929, but its effects lasted for a long time. The economy was booming with happy days. Then, the stock market crashed and everything went haywire. It was almost impossible to predict, like trying to guess the lottery numbers but on a global scale. The world had never seen such a massive economic meltdown. At its peak, 25% of Americans found themselves without a job. The economy took a nosedive. The US GDP dropped by 30%. Over 9,000 banks waved the white flag and said, "We're out." Oh, and there's something called a gray swan event, too. It's not as rare as a black swan, but it's still an outlier. The good news is that gray swans are a bit more predictable than black swans, so we can better prepare for them and take some measures to protect ourselves. Let's play a little thought game. Imagine we're weighing a bunch of people, and one of them happens to be the heaviest person in the world. Even if that person weighs 2,000 pounds, it doesn't really make a big difference in the overall average weight of everyone we weigh. It's like a drop in the bucket. This shows that extreme outliers like this super heavy person don't have a huge impact on the average. Now let's do a similar experiment, but this time with wealth. We gather a group of people, including one billionaire. What if that billionaire's wealth is 99% of the total group's wealth? Unlike the weight example here, the outlier dominates everything else. This is what Taleb calls extremistan, where a small number of people have a huge portion of wealth, while others have very little. Taleb argues that the modern world operates more like money. It's mostly digital and not constrained by physical or biological limits. While most people don't make a lot of money, a few can make a ton. The same applies to other areas like music, book sales, and more. This winner-take-all system rewards a small number of individuals disproportionately. We tend to believe we understand why these outliers exist. We think it's all about thinking outside the box, starting a revolutionary company, and working tirelessly. But what about those people who did all these things and failed? You don't often hear about them or find shelves full of books about their failures. There's a bias in the stories we hear and the information available to us. In the end, we became more vulnerable to black swans. So, whether it's a mold leading to life-saving antibiotics or an economic crisis, these events of the black swan theory show us that unexpected events can have impacts on our lives. By the way, the odds of being born are 1 in 400 trillion. For all we know and don't know, being born is an unimaginably improbable event that nobody could have truly foreseen. So if you're alive, in a sense, you're a black swan too.
Voyager 1, which has been traveling through interstellar space for more than 45 years and is trailing a long gray beard by this time, not really, it suddenly began to send strange signals to Earth. Even more bizarre, there are no signs that the probe has broken or anything. Scientists from NASA are desperately trying to find the reason. So, what's happened exactly? First of all, let me tell you a bit more about Voyager 1 and its long journey. Voyager 1 is an American space probe. Scientists from NASA sent it into space on September 5, 1977. Voyager's goal was to explore the outer planets of our solar system, namely Jupiter and Saturn. Initially, scientists assumed that the mission would take about 5 years. The joke's on them. The probe exceeded all expectations. Not only did it fulfill its mission, but it's still working for much longer than expected. Voyager 1 has been wandering around space for more than 45 years. It's hard to estimate what Voyager 1 has done for science. Firstly, it successfully sent a lot of photos of Jupiter and Saturn to Earth. By the way, you can even check out these photos yourself. All of them are published on the NASA website. Thanks to Voyager, we also discovered several new moons of Jupiter and a previously unknown system of its rings. We learned that Jupiter's famous red spot is actually a giant superfast storm. And after leaving Neptune's orbit behind, Voyager also sent a lot of important data about interstellar plasma. So Voyager 1 successfully proved to scientists how useful it was. After that, it happily headed for its next goal, the Kuiper Belt and the heliosphere. The Kuiper Belt is a ring of icy bodies that extends from Neptune to a distance of approximately 50 AU from the Sun. It's kind of similar to the asteroid belt, but about 20 times wider and 100 times heavier. And the heliosphere is an area around the Sun where the pressure of the solar wind is balanced with the pressure of interstellar gas. Yeah, I know, it sounds like some hard scientific stuff. Just keep in mind that this data really helps us understand the universe as a whole. So, this is Voyager's last task, to tell us more about interstellar space. The probe has already sent us more than 60 frames for a mosaic of the solar system from a distance of over 4 billion miles from Earth. Scientists used these frames to make a big colored picture. The photo was called the pale blue dot, and you've probably already guessed what that dot is. Yep, that's what our Earth looks like through Voyager's eyes. This photo clearly shows how tiny we really are, and how precious and fragile our planet is. But Voyager 1 also has another, even more important mission, to tell other civilizations about us humans. You might have heard about the famous Voyager Golden Records. People created many audio and video files and added them to these records. There are a few sections. The first one contains hello in 55 languages, including ancient and extinct ones. Almost 80% of the recordings are different musical pieces, like Bach, Beethoven, Mozart, and Stravinsky. Folk music from different countries and ages, and a bit of the blues, like famous songs by Louis Armstrong and Chuck Berry. The remaining 20% of the recordings contain different human voices, sounds of nature and animals, as well as 116 images encoded as audio signals. There's also recordings of speeches by Kurt Waldheim, a former UN Secretary General, and Jimmy Carter, a former US President. These are just some friendly messages. In addition to the records, scientists also packed a needle for playing them. Don't worry, they also left a simple drawing that showed how to use all this stuff and how to translate the sounds into pictures. They added Earth's coordinates, which they created using a pulsar map. It shows the position of the Sun in the Milky Way. The record was packed in an aluminum case and covered with gold to protect it against radiation and cosmic dust. Carrying this record, Voyager 1 set off on its long journey, and it has already traveled quite a distance, I'd say. Right now, Voyager 1 is 154 astronomical units away from us. That's about 14.5 billion miles. This makes it the most remote human-made object. Initially, this title belonged to the Pioneer 10 mission, but Voyager overtook it in 1998. What a bargain for NASA! It's way beyond its best-by date. Voyager 1 is actually so cool that it even overtook its twin brother, Voyager 2, which, by the way, had been sent into space 2 weeks earlier. Voyager 1 moves at a speed of 9.7 miles per second. That's 35,000 miles per hour. Even the fastest sports car in the world travels at a speed of only 305 miles per hour. So it's hard to imagine the speed of Voyager. Anyway, at the moment, Voyager is heading to the borders of the Oort cloud. That's the name of a hypothetical layer of icy objects surrounding the solar system. Astronomers haven't confirmed its existence yet, but they're almost sure it's there. After all, even black holes were only a theory not so long ago. Unfortunately, Voyager 1 won't return back to the solar system. It'll keep in touch with Earth at least until 2025, but eventually we'll lose the connection with it for good. In 300 years, it'll reach the borders of the Oort cloud, and in 30,000 years, I won't be around then, it'll finally leave the solar system. And if nothing happens to it along the way, in another 10,000 years, Voyager 1 will approach red dwarf star Gliese 445 in the Giraffe constellation. In the future, the probe will probably keep wandering around the Milky Way galaxy. And now, let's finally discuss the mysterious signals part. So, what happened? Well, a rather unusual thing. NASA's Jet Propulsion Laboratory, which monitors and controls both Voyagers, reported this problem in May 2022. Our veteran spacecraft suddenly began sending strange data to Earth. The whole situation puzzles even engineers from NASA. Now, I bet you're thinking, come on, the thing just probably broke down or something. But the truth is that Voyager 1 is totally fine. It works as usual, receives and carries out commands from Earth, and collects and sends scientific data. But the readings of the AACS, which stands for Attitude and Articulation Control Subsystem, don't show what is actually happening to Voyager anymore. This system supports the orientation of the probe in space and helps it keep in touch with Earth. So, basically, the signals mean that the probe's orientation in space is messed up. But scientists claim this is not the case. They know that the source of the antenna signal remains in the same position relative to Earth as planned. The problem hasn't triggered any of the onboard fall protection systems. The probe hasn't even entered safe mode. So, what in the world, or universe, is going on? Suzanne Dodd, the head of the project, says that the problem is not actually that unexpected. After all, Voyager 1 is already 45 years old. The expert admits that what's happening to the probe remains a mystery to them. They don't know exactly where the incorrect data is coming from, and it's unclear how this will affect the operation of Voyager. She adds, though, that it's not that surprising, considering that the probe is in interstellar space. There's a very high level of radiation there. No spacecraft has ever reached that point before. Scientists from NASA say they'll keep closely monitoring the data coming from Voyager 1 until they figure out the problem. If they find it, the management team will try to fix it. Otherwise, the team will have to adapt to the new conditions. It might not be enough just to understand the problem, though. It takes as much as 20 hours and 33 minutes to receive the signal from Voyager, and it takes the same amount of time to respond to it. Well, at least the second spacecraft, Voyager 2, is totally fine, even though it's also currently in interstellar space at a distance of 12 billion miles from Earth. Anyway, we can only wait for news and hope that the problem will be resolved. I actually wonder how much longer can Voyager 1 last? Will it be able to fly to the borders of the Oort cloud in 300 years? What do you think? I'd like to hear your thoughts in the comments.
All the planets of the solar system are slowly lining up. Mercury, Venus, Earth, Mars, Jupiter, Saturn, and Neptune are about to form a straight line. This event, called the Parade of Planets, occurs once every 176 years. The last time this happened was almost 40 years ago, and it was a great chance to explore all these planets in one go. On August 20th, 1977, thousands of people gathered outside NASA's Kennedy Space Center. They came to witness the launch of the most ambitious and distant space mission in history. 5, 4, 3, 2, 1, ignition! Launch rocket Titan took off from Earth and left the atmosphere. As soon as the rocket reached outer space, it launched the probe Voyager 2, which began its journey. The probe consisted of a bus 1.5 feet in height and almost 6 feet wide. On top of it, there was a round 12-foot wide antenna. Most of the scientific equipment was mounted on a boom that extended 8 feet outward. On September 5, 1977, Voyager 1, the identical space probe, left our home planet. It sent us pictures of Earth and the Moon. It soon overtook Voyager 2, launched 2 weeks earlier. That's why the second probe has the number 1 in its name. And so the journey through dark space began. March 5, 1979. About 4 Earth-Sun distances away from our planet, Voyager 1 came close to Jupiter and prepared its scientific equipment to explore the planet. The probe had a dozen gadgets, including a 2-camera system with narrow and wide-angle lenses. So, it could take full-length photos of the planet with the wide-angle camera, as well as close-up photos of specific places on the planet and its satellites. The probe also had a radio science system to determine the atmospheric composition, weight, and gravitational fields of the planets it came across. Infrared and ultraviolet spectrometers could help measure radiation and temperature invisible to the human eye. Various sensors were used to examine cosmic rays. Voyager 1 was the first to find volcanoes outside Earth. Those were on Jupiter's satellite, Io. It has dozens of active volcanoes that constantly spew lava. Then the probe pointed its cameras at the Great Red Spot. That's how people learned that it was a giant cyclone-like storm that hasn't stopped for the entire history of observations of Jupiter. It was also the first time when lightning was detected outside of our home planet. And in the invisible spectrum, Voyager 1 noticed that Io acted like an electrical generator for Jupiter. Ions, which are charged particles, were constantly flying toward the gas giant. This electrical current was 5 million amps. Soon, Voyager 1 continued its journey. 5 months later, Voyager 2 approached Jupiter too. This gas giant has rings around it. They're not like Saturn's though. Jupiter's rings consist mostly of dust. When the planet's rocky satellites collided, they turned into small debris. Gradually, this debris turned into fine dust. Then Voyager 2 approached Europa. This moon is completely covered by a crust of ice, and beneath it, there may be a liquid ocean where life can possibly exist. Voyager 2 was the first to capture the cracks in Europa's ice crust. While flying near Io, Voyager 2 discovered that 6 volcanoes on its surface were still erupting. This meant that the periods of activity of these volcanoes could last for months. Both space probes circled the gas giant several times and then dashed further into space. Such a gravitational maneuver allowed them to gain more speed and saved fuel for the trip. By November 9, 1980, Voyager 1 had already traveled 8 Earth-Sun distances away from home. The space probe arrived at Saturn. It discovered 3 new satellites of the gas giant: Atlas, Prometheus, and Pandora. This proved the theory that these were the moons that kept the planet's rings in line. It also turned out that unlike Jupiter's, Saturn's rings also contained ice. Voyager 1 took a peek at Titan, Saturn's largest satellite. It's 50% larger than the Moon and even has an atmosphere. It's the only place in the solar system besides Earth where liquid water has been proven to exist. That's why scientists don't deny the possibility of life there. Then it was time for another gravity maneuver. Voyager 1 once again darted away from the planet's orbit. This time, it was aiming upward relative to the line of the Parade of Planets. Almost a year later, Voyager 2 arrived there. It made a flyby of several of Saturn's icy satellites. Supposedly, a long time ago, these moons collided and knocked huge chunks of ice and rock out of each other. This debris orbited Saturn, collided, and slowly crumbled into dust, consisting of ice and rock. This is how the famous rings of Saturn were born. Another gravity maneuver, and Voyager 2 set off for the next gas giant. 5 years later, it arrived at its destination, 17 Earth-Sun distances away from our planet. For the first time ever, a human-made object approached Uranus. Voyager 2 discovered 11 new moons there. The probe also found that Uranus was the coldest planet in the solar system. Its temperature is negative 350 degrees Fahrenheit. That's 4 times colder than the temperature at the South Pole. At that time, the Deep Space Network was being tested on Earth for the first time. It's a network of radio telescopes all over the planet. They aim at certain points in the sky to establish communication with extremely distant objects. These telescopes have been successfully receiving signals from Voyagers 1 and 2. August 25, 1989. Voyager 2 had already traveled 23 Earth-Sun distances and arrived at Neptune. It was the first time people received images of this blue planet from such a close distance. The probe discovered 6 new moons there and also took the first pictures of the planet's rings. Engineers then turned off the probe's cameras to save power for its main computer and the instruments that measured the solar and interstellar wind. Voyager 2 left Neptune and headed into deep space. That's why it no longer needed the cameras. A few months later, Voyager 1 sent its last photo back to Earth. It was a family portrait of our entire solar system. Every pale dot was a planet. You can barely recognize Earth in the picture. After that, the camera was turned off to save power. This was the start of the interstellar mission for Voyager 1. For 15 years, Voyager 1 had been flying to the edge of the solar system. On December 16, 2004, the probe passed through the termination shock. This is where the solar wind suddenly slows down and heats up after colliding with the interstellar wind. The space probe managed to endure this test and continued its journey. In 2007, Voyager 2 crossed the same boundary. At that point, sensors recorded a temperature of about 266 degrees Fahrenheit, but the probe managed to withstand it and continued its journey through the dark cosmos. Both Voyagers moved through interstellar space in different directions. They discovered that the heliosphere, the solar wind bubble, is not perfectly round, but more like an egg. August 25, 2012. Voyager 1 became the first human-made object to enter interstellar space. It's now also the most distant artificial object in human history. On November 5, 2018, Voyager 2 also left the solar system. The 2 probes continued their journey into deep space. Right now, the Voyagers have been operational for 44 years. Voyager 1 has traveled 153 Earth-Sun distances and is moving forward at 38,000 miles per hour. In about 300 years, the probes will reach the Oort cloud. This is a hypothetical region around the solar system with nothing but asteroids and blocks of ice. Scientists believe they might reach the nearest stars in the next 40,000 years. Perhaps one day, the Voyagers will enter these star systems and explore unknown worlds. There may be planets there that look like ours. The probes may even be able to find an intelligent civilization there. For this purpose, each Voyager carries a golden record with a message on it. There are 115 images. Among them, there's our number systems, a map of the solar system and pictures of its planets, diagrams of human DNA, portraits of people, and landscapes from Earth. There's also greetings in 55 of Earth's languages, including the oldest and newest of them. There are also 90 minutes of music from every corner of our planet. The Voyagers also carry a device to play these sounds. If another civilization gets this record, their scientists could decode the data step by step. And then, that civilization may decide to pay us a friendly visit. They'll have to repeat the heroic journey of the Voyagers, though. Dozens of light years through dark space. Then crossing the border of the solar system, and finally flying past Neptune, Uranus, Saturn, Jupiter, Mars, and the asteroid belt toward the little blue planet. We can only hope that people will be advanced enough to welcome them.
Whoa! A wall of fire spreads around the epicenter of the impact. It burns everything in its path. The waves raised by the explosion cover large cities, and earthquakes are so strong that giant skyscrapers fall like a house of cards. So, these are the possible consequences of the collision with the first interstellar object in history to visit our solar system. We discovered it in 2017, but we're still not sure what it is: an asteroid, a comet, or a spaceship of some outer space civilization. So far, scientists have named it Oumuamua. Sounds like a Hawaiian cow. Well, whatever it is, its speed is much faster than other asteroids, about 54 miles per second. At that speed, you could cross the US from coast to coast in less than 3 minutes. So this asteroid could travel from Earth to the Sun in about 2 months. By comparison, our rockets can travel up to 17,000 miles per hour. The same trip across the United States would take them about 9 minutes. So, many scientists speculate that this is an artificial object created by a very advanced civilization. Okay. The shape of the object supports this theory. It's long and narrow and resembles a spaceship. It's about half a mile long, way bigger than the Eiffel Tower. Scientists decided to see if Oumuamua was really someone's spaceship and pointed some radio telescopes at it. If the civilization on that ship had used communication or scanned us with their tech, we would have known about it. But there was complete silence. Kind of like that. Not a single radio wave. But that doesn't disprove the theory of outer space civilization. To find out for sure, we decided to determine the weight of the object. To do that, we use light. More precisely, its reflection. You see, different materials reflect light differently. We take an unknown black stone, for example. It absorbs almost all the light, reflecting almost nothing. Check out the catalog, it's charcoal. Knowing the size and material of the object, we can determine its weight. So, we need to see how much light this object reflects. And when scientists pointed their telescopes at Oumuamua, they learned that it reflects colors that match with iron and also with some solid rocks. And Oumuamua was flashing all the time, a bright flash. Then it would slowly fade, and then it would start to shine again. This means it was spinning. And it wasn't going around its axis like an arrow. It rotated chaotically, moving its edges up and down. Any artificial object or spacecraft would have been torn apart by such overloads. But Oumuamua is still intact. That means it's made of super hard materials that keep it from falling apart. And it's not hollow like a spaceship. It's one solid body. Hey, like me. The astounding speed of this object makes it pretty mysterious. Some comets can have the same or even higher speed, but they also have a kind of rocket effect. So when a spaceship starts from the launch pad, you see fire bursting out of its engines. Every second, the rocket mixes fuel with oxygen, ignites them, and ejects them at a tremendous speed. According to the laws of physics, this is like pushing off a wall. The rocket sort of jumps up from the combustion gases it throws down. That's how the rocket creates thrust and accelerates. Comets work on a similar principle. The sun's rays hit the surface of the comet. Light elements like ice start to evaporate. That gas goes one way, the comet goes the other. Just like a rocket, the comet is pushing off the evaporating gas and accelerates. This gas also forms the comet's long tail. It's as if the massive rock is dragging all this gas behind it. I can relate. Or it's like a car pulls air with it when it goes at high speed. But Oumuamua is not a comet, and it doesn't have that tail, and it doesn't have the same rocket effect as a comet, so it couldn't have accelerated to that speed. But some scientists believe that Oumuamua used to have a tail. Although we discovered it in 2017, it entered our solar system in 1995, and it was hit by the sun's rays even back then. When we discovered this asteroid, it had already lost about 95% of its mass. It simply evaporated. Other scientists believe that Oumuamua got this velocity during its birth, somewhere far away in another star system or nebula. Perhaps it was a dramatic collision of some exoplanet with another cosmic object. The colossal explosive energy of the collision threw the elongated shard into outer space. Or it could have been a supernova explosion. When a star reaches the end of its lifespan, it becomes a red giant. It's an inflated version of the star, hundreds of times bigger. Then it shrinks and explodes with tremendous force. The blast waves can travel many light years away from the epicenter. and it's one of the brightest events in the universe. So, the supernova might have torn some exoplanet to pieces. One of them, Oumuamua, gained a lot of energy and speed and began its long journey toward Earth. This might explain why Oumuamua keeps spinning so wildly. But recently, scientists published a theory that Oumuamua may be a giant block of ice. The kind of ice we're used to is water, H2O, but Oumuamua could be nitrogen ice, N2. It may have remained intact in interstellar space for 500 million years. And when it arrived in our solar system, nitrogen ice could have reflected 2/3 of the sun's rays, so it didn't heat up as much. That explains why Oumuamua doesn't have a tail. You can find the same nitrogen ice on Pluto, as well as on Triton, one of Neptune's moons. So Oumuamua comes from a similar icy exoplanet. But we can find out for sure only by sending a space probe to it. Scientists came up with a plan for that called Project Lyra. The problem is that Oumuamua is leaving our solar system at tremendous speeds, much faster than our rockets can fly. And we need to catch up with this space rock as quickly as possible before it gets too far away. To do this, we can use a gravity maneuver. First, the space probe makes a flyby of Jupiter. It passes close to it to take advantage of its gravity to accelerate. After that, the probe will head towards the Sun, and it'll fly around it as close as possible to fire like a catapult towards the space rock. The second option for reaching the asteroid is to use microprobes. We have to launch about 1,000 of them into orbit. They should be no heavier than a match. Each of them will have a light sail the size of a boxing ring. Then we'll focus a powerful laser beam from the ground onto this sail. It will allow us to accelerate the probe to about 20% of the speed of light. It shouldn't go too fast not to fly past the asteroid. It should be able to enter its orbit or land on it. But if we're too slow, Oumuamua will leave our solar system before we can catch up with it. It'll be a great experience because in the future, we'll be able to use such asteroids as a space taxi. All we have to do is enter the orbit of such an interstellar asteroid or even land on it. Then we would keep moving through space at incredible speeds without using any fuel at all. This would be a great option for traveling long distances or to deliver supplies to other star systems. So why should we be afraid of such objects? Well, a collision with an asteroid the size of Oumuamua could wipe out an entire state. If it were to hit somewhere in the ocean, it could cause waves taller than our skyscrapers. Scientists are anxious to find ways to protect us against such objects. One of them is ramming. If we spot a potentially hazardous object, we could send a spaceship towards it, pedal to the metal. The spacecraft will have to ram the asteroid at an angle that will move its trajectory just a little bit. Moving it too much on a cosmic scale would only dramatically change the asteroid's final destination, and we only need to get the asteroid past our planet. We can also create a controlled explosion on the asteroid. It's based on the same principle. The force of the explosion would have to shift the trajectory of the asteroid slightly, or smash a giant rock into smaller pieces. Asteroids up to 80 feet wide would burn up completely in our atmosphere due to friction against the air. Rocks between 80 feet and half a mile in size may not burn up completely and cause local damage. Anything larger is considered very hazardous. You think? The traditional method of science fiction is to put rocket engines on the asteroid. Then we can not only change the trajectory of the space rock, but also control it. And we can use it against other asteroids. It would be something like space billiards. Strange explosions in vibrant blue colors are popping up around the universe and keeping astronomers intrigued. This rare and incredibly powerful event has a fancy name: luminous fast blue optical transient. This phenomenon doesn't behave like anything else we know of, and things got even stranger when the most recent one happened in a spot it shouldn't have. To really understand what happened last year, we need to go back a bit. This type of strange explosion was spotted first in June 2018. The blue blast happened about 200 million light-years from Earth and got the nickname the Cow. No, this happening didn't resemble a cow at all, but it did have an unusual format. Back then, this blast was the most asymmetrical explosion ever seen by astronomers. It burst into space in a flattened pancake-like shape, not in a typical sphere as they would expect. This phenomenon was similar to a supernova, which is the most common type of cosmic explosion that happens when a star exhausts its nuclear fuel and collapses under its own gravity. However, scientists also noted three crucial differences. Number one, this phenomenon is more powerful than a typical supernova. When it happens, the blue burst emits more energy than an entire galaxy of hundreds of billions of stars like the Sun. Number two, it's much faster. The explosion reaches its peak brightness and fades away within a matter of days, while a supernova can take weeks or even months to completely dissipate. And the last difference, these blue bursts can also be much brighter. These mysterious objects are considered the brightest known optical phenomenon in the universe. But unlike a regular supernova, it's believed that there are no radioactive elements to power this brightness. So that means the power must come from somewhere else. The question is, from where? This is just one of the mysteries that the scientists are trying to figure out. There have been some heavy investigations since the event was first observed, and 15 telescopes around the world are constantly looking for it. Since 2018, these extreme explosions have been spotted about once a year. So while they're rare, they're not incredibly uncommon. There are several possible explanations for the existence of these fast optical transients. Perhaps the most acceptable one is that it is a stellar corpse. I mean, what is left behind when a star calls it quits. So we're looking at two prime suspects here. They could be a neutron star or a black hole, producing emissions close to the speed of light. The theory goes like this. There is a massive star much larger than those that produce regular supernovas. Then it starts to collapse. Such an event would certainly be expected to leave a black hole behind. Let's say this massive star isn't ready to leave the universe in a quiet way. Instead, it creates a swirling disk around the black hole composed of gas, dust, and other matter, like it matters. This disk, called the accretion disk, can shoot out streams of material at incredibly high speeds, almost like powerful cosmic jets. And that could be exactly what we see as those sudden bursts of light. Again, it's just a theory. What exactly sets off these blasts remains a mystery, and much more observation and analysis are needed. Experts believe that explaining such an oddity is a scientific goldmine. After all, we're talking about a stellar corpse that isn't just sitting there, it's actually quite active. Now, since this event was first spotted, all similar occurrences that our telescopes have captured happened in the same place. I mean, the explosions always occurred in the spiral arms of different galaxies. But last year, things changed. The Hubble Space Telescope left scientists speechless in April 2023 when its images caught this same type of weird explosion happening for the first time in the middle of nowhere. Well, it didn't happen inside a galaxy as it was supposed to. It happened in the space between two of them. More precisely, about 50,000 light-years from a large spiral galaxy and about 15,000 light-years from a small one. This event is known today as the Finch. Oh great. So when we finally get closer to finding some answers, the unusual location of the Finch phenomenon came to mess it up again. So maybe there is another explanation for it. Speculation began soon after the discovery. One idea is that it could have been a collision between two neutron stars traveling far outside their host galaxies. These two could have been spiraling toward each other for billions of years, and when they collided, they produced a flare over 100 times brighter than a normal supernova. For this hypothesis to be correct, one of these neutron stars would have to be highly magnetized, amplifying the explosion. Another possibility is that the explosion was a star being torn apart by a black hole with a mass between 100 and 1,000 times that of the Sun. Although we still have lots of questions, one thing is for sure. The Finch is a luminous, fast black optical transient. Except for the weird location where it happened, it has all the other characteristics to be classified as one. It's super bright, like me, and super fast, and its origin is super hard to explain. Plus, the data from the Gemini South Telescope, the Chandra X-ray Telescope, and the Very Large Array Radio Telescope have confirmed it. Adding this latest information only makes it harder and harder for researchers to finally find some kind of pattern in this whole event. The Finch isn't the only peculiar event in this category. Let's head back to the year before, to 2022. A blue explosion was spotted in September, and it got the nickname of Tasmanian Devil. Just like the previous ones, this blue burst came up and disappeared very quickly. Then, something mysterious happened. Exactly 100 days later, observers who were still tracking the phenomenon got an early Christmas gift. They observed another flare-up, and it was as bright and fascinating as the original one. Wait, so we're talking about two similar and strange explosions that happened at the same spot and close in time? Well, this was a first. Quickly, 13 telescopes around the globe all had eyes turned toward the Tasmanian Devil event, including one equipped with a high-speed camera. Over the course of 120 days, they managed to capture another 14 irregular light pulses. This was certainly amazing because it proved that instead of showing up once and fading away as expected, the Tasmanian Devil continued to explode with supernova-like energies again and again and again. Can you imagine such power? This scenario still intrigues the scientific community because it pushes the limits of physics, not only because such extreme energy production, but also because of the short duration bursts. By the way, its flares last from 10 minutes to about 4 hours. Believe me, on the scale of the universe, that's considered super quick. This was the only time that an extended season of this event was observed. However, after some thought, the scientific community split their opinions about it. On one hand, the Tasmanian Devil could have been an utterly unique and one-of-a-kind event. On the other hand, maybe it was just the first time that our telescopes caught it from a more face-on angle. To further understand what's happening, scientists still need to observe larger samples of the phenomenon. All hopes are in the upcoming Vera C. Rubin Observatory, which is currently being constructed in Chile. It will have a 27.5-foot-wide telescope, coupled with the world's largest digital camera ever fabricated for this purpose. According to NASA, this technology might finally give us some answers about these blue explosions. We can expect some exciting times ahead, as this could be the start of a new chapter in our understanding of stellar evolution.
On November 2nd, 2000, the first crew of astronauts arrived at the International Space Station. Almost 25 years have passed, and the ISS still remains one of the most outstanding projects created by humanity. During all this time, 280 astronauts from 23 countries have visited the station. This place has become a floating laboratory for space research where people from all over the world come together to explore our universe. The station remains a source of inspiration for writers and movie directors. This is not only one of the most important parts of the scientific field of humankind, but also an important attribute of pop culture. The station makes one circle around Earth every 90 minutes, and very soon, one of its next circles will become the last one. NASA is going to destroy the ISS. Space and science fiction fans may feel sad at this moment, but there are good reasons for such a difficult decision. The ISS, like any physical object, is not eternal, especially in the conditions of outer space. Yes, there's no oxygen, atmosphere, oxidation of materials, and air pressure, but the ISS is moving at an altitude of about 260 miles above the Earth's surface at a speed of 17,900 miles per hour, which is almost 20 times faster than the speed of sound. Also, the space around the planet is filled with debris consisting of broken satellites. And don't forget about stardust and tiny pieces of meteorites. What if something crashes into the station and blows it to pieces? Yeah, NASA is tracking the largest pieces of debris, but there are more and more of them every year. Under such conditions, the station can't serve us forever. The parts are wearing out, and the station fasteners are becoming weaker and require frequent repairs. The station was supposed to only last 15 years, but it will eventually last twice as long. In 2030, astronauts will leave the ISS, and then it will be destroyed. But how can this be done, given the size of this object? It weighs 430 tons and is the size of a football field. It is the largest object after the Moon that flies around our planet. People made 42 launches into space to construct this gigantic structure. Given its size and close location to Earth, destroying the station is a big risk. Just imagine it disintegrating into hundreds and thousands of fragments and falling to the surface of our planet. Yes, some of these chunks will burn up in the atmosphere. Others will fall into the water. But some large parts can fall on cities. It will be a devastating meteor shower. This option is too dangerous, but this is exactly what NASA is about to do. The disposal of the station will probably be a more complex operation than its creation. Of course, scientists have considered other options besides the destruction. For example, we could return all the astronauts to Earth and then send the station to a higher orbit so that it would fly there forever. However, such an operation would be too expensive. In addition, changing the orbit might not save the station from collapsing. We definitely don't need a huge piece of metal that could fall apart at any moment over our heads. That's why destroying the station is the only option. To destroy the station, scientists plan to send it to a lower Earth orbit, then carry it through the atmosphere, where some parts of the station will burn, and after that, submerge the station in a remote part of the ocean, where ships don't sail and fish don't swim. By the way, this place is called Point Nemo, and it's located in the South Pacific Ocean. This is the farthest point from land. For many years, people have been dumping space debris and failed satellites there. It's considered one of the most lifeless and loneliest places on Earth. NASA plans to drop the ISS there, but this requires very precise calculations and control. The operation can't be fulfilled without a special space tug, and this unique machine will be invented by Elon Musk's SpaceX company. Musk signed an $845 million contract with NASA. According to it, the station should be safely destroyed by 2031. And that's how this cinematic operation is going to happen. The device that will lower the ISS to Earth will be built according to the design of the SpaceX Dragon ship capsule. Scientists plan to calculate the details of the station's flight trajectory, all angles of incidence, and the speed of movement. No mistake can be made, as any miscalculation will lead to disaster. Our planet is a giant object with a powerful gravitational force that attracts other objects to itself. The ISS uses thrusters to resist this attraction and stay at the same height. So, first of all, the station will need to reduce its resistance. If necessary, it can use the engines to adjust the route. From an altitude of 260 miles, the station will descend into an orbit of 205 miles above Earth. After that, SpaceX will launch its space tug. All this will happen about a year before the scheduled date of destruction. During this time, the astronauts will fold up scientific equipment, say goodbye to the station, and return home. This sad moment will be recorded on camera and posted on the internet. After that, the whole planet will watch the dramatic finale of the ISS. The space tug will dock with the station and transport it to the lowest point of the orbit, approximately 90 miles above the surface. There, the station will experience huge air resistance. It will become increasingly difficult to control the fall. The tug must be equipped with powerful rocket engines to correct the flight. Scientists will control the shuttle, calculating the trajectory of the fall. Then, SpaceX's device will begin to push the station down. The giant space object will pass through the thickest and most dangerous layers of the atmosphere. It will burn down the station, which will be falling apart by that time. This will be a mesmerizing fire show. Some parts will burn up in the air, others will pass through the barrier. At high speed, incandescent parts will collide with the surface of the Pacific Ocean. Millions of people will be watching the last flight of the space legend on the screens of their gadgets and TVs. The water will be getting closer, and boom! Pieces of those stations will crash into the water with a deafening noise. Many smaller fragments will fall nearby. The entire station will cool down quickly and sink to the ocean floor. Mission completed. But the history of the station won't be over. Point Nemo is 2,700 miles away from the nearest land in any direction. But the best way to get to it is from Easter Island, Chile. What if rich people from all over the world flew to Chile to then travel to Point Nemo? Just imagine, covering thousands of miles just to get to the ISS crash site. People will descend in bathyscaphs to the ocean floor and take out the wreckage of the station. Someone might start selling them. Someone will keep them at home as part of a collection. Perhaps NASA will retrieve some modules of the station to put them in a museum. But what will happen once scientists finally get rid of the ISS? The space laboratory is used for research in outer space. After its destruction, research will continue, but on a grander scale. Humanity has to explore Mars, remember? For such an important mission, it's necessary to prepare astronauts in conditions close to those on the Red Planet. The Moon is the perfect place. NASA is conducting the Artemis mission. We'll explore the lunar surface, and we will go on a long journey to Mars from there. At the end of 2022, NASA launched a probe that flew beyond the Moon. The next flight will be launched with people on board. The third flight will be the first human outing on the Moon since 1972. Gradually, step by step, the agency plans to land several astronauts and space station modules on the surface of the Moon. They will build large research bases where they will prepare for the first ever human flight to Mars. By the way, would you agree to go on a dangerous journey to the Red Planet? Write your answers in the comments.
You know what? 8 out of 10 people worldwide can't see the Milky Way anymore. And in just 100 years, it might turn into a forgotten tale from the past. It's not that the galaxy is disappearing, but that the cosmos is fading from view. Back in our grandparents' day, they could look up and see this vibrant tapestry of stars. But nowadays, we're lucky if we can even count them on one hand. This has nothing to do with nature. It's all because of the creeping threat of something called light pollution. Next time you walk around a big city after dark, take a moment to notice the large number of street lights, neon billboards, and office buildings shining all night long. Those endless city lights create an artificial brightness that competes with the natural glow of the stars. This is light pollution, and it's getting worse. Every year, Earth gets 10% brighter. That means if someone is born today in an area where you can typically see around 250 stars, when they reach 18, they'll only be able to see about 100 of them. Unfortunately, that's already a problem in big cities, where looking up at the stars is becoming something that you can only do in planetariums. It's gotten to a point where, during an earthquake that knocked out the power in Los Angeles in the 90s, many residents called emergency centers to report a massive silvery cloud in the night sky. But what they were actually seeing, perhaps for the first time, was the Milky Way. When you look at Earth from space, you can see vast areas of North America, Europe, the Middle East, and Asia all lit up. Singapore, Qatar, and Kuwait are some of the most light-polluted countries. On the flip side, remote places like Siberia, the Sahara, and the Amazon rainforest are in total darkness. Light pollution shows up in many forms. First, there is glare, like when you're driving and those bright lights literally make your eyes hurt, leaving you very uncomfortable. Then there is clutter, like Times Square with its crazy mishmash of different bright lights all over the place. Light trespass is when light sneaks into places it shouldn't, like a streetlight shining right into your bedroom. And finally, there is over-illumination, which is just using way too much artificial light for no good reason, like keeping all the office lights on throughout the night when no one is even there. All these forms of light pollution aren't just stealing the beauty of the night sky, They're also interfering with astronomical studies. When we rely too heavily on artificial lights, it messes up the work of Earth-based telescopes. And when that equipment can't do their job properly, we end up needing even more expensive space telescopes like Hubble and James Webb. And let's face it, that costs us billions. Turning night into day actually affects all of us, not just astronomers. Nighttime light messes with our sleep schedule and our body's internal clock. This clock keeps things like brain activity, hormone levels, and cell functions on track. So when it's disrupted, it can lead to serious issues like depression, insomnia, heart problems, or worse. One key process that gets messed up is the production of melatonin, a hormone that kicks in when it's dark. Too much light at night lowers melatonin levels, leading to stress, anxiety, headaches, and sleep deprivation. Blue light is the main villain here. You might think that turning on night mode and getting that orange glow in your phone screen is enough, but it's not. Blue light is also present in LED bulbs, the kind we use at home and in city lighting, because they're cheap and energy efficient. My point is that blue light is basically everywhere, and it's a real challenge to avoid it completely. This is also a big part of why we're not entirely sure how bad light pollution is nowadays. I mean, some statistics suggest that this issue increased by 49% over 25 years, up to 2017. But the real figure may be even higher. The thing is, blue light has shorter wavelengths, and the satellites we depend on today struggle to detect it accurately, meaning they don't quite capture the full extent of the light pollution caused by LED lights. Animals are lost and confused too. Their sleep patterns are also affected. A study from Germany revealed that blackbirds in urban areas are getting active much earlier than those in natural habitats. They wake up and start singing up to 5 hours sooner than their country cousins. Migration behaviors are messed up, especially for birds like sparrows and thrushes who travel at night. You see, they rely on the moon and stars as their internal GPS. So you can imagine how disoriented they get when they spot something like Las Vegas's massive sphere, lit up by 1.2 million LED bulbs. The intense brightness hides stars and disrupts their navigation across thousands of miles and continents. And it's not just that. Artificial lighting is unfortunately causing more birds to crash into skyscrapers and high-rise buildings. Insects, like mosquitoes, are also affected by light pollution. Yep, they're kind of gross, so it might not bug you if they're attracted to artificial lights and meet their fate. But remember, they're a crucial food source for many animals, like bats or frogs, so disrupting their populations could throw off entire food chains. Nighttime lights are causing problems underwater as well. Marine creatures near brightly lit panels off the Welsh coast are changing their behaviors, and fewer sea squirts and sea bristles are hanging out near those lights. Another example involves sea turtles. They typically lay their eggs on beaches and often return to the same spots for years. But when those beaches are too bright at night, female turtles might become confused and decide not to lay their eggs there. Now, do we really need all this light? It's hard to say. Some people might feel safer at night, while others think the opposite. You see, it's usually the glare that messes up our sight. Here's an example. If there's a super bright lamp blocking our view, say at a gate, we can't see anything but the light. But check this out. If we partially cover the light with our hands, suddenly we can spot an intruder. Wow. What I mean is that more lamps don't always mean more safety. It's all about using them the right way, and doing things like dimming lights can actually enhance security. Plus, it could save you some cash. Speaking of which, light waste has a pretty big impact on the economy. Take a Cobra Head streetlight, for instance. The light projected directly by it is only 30% of the total light it emits. In the US alone, roughly 1/3 of the light at night goes to waste, and that adds up to a staggering annual cost of $2.2 billion. Electric lights aren't all bad, of course. They have done some good stuff for us, like making our days longer so we can get more done and have some fun after work. But we can totally minimize this issue. Turning off all the lights would be awesome, but let's be real. That is very difficult, if not impossible these days. So, what can we do? Get those fancy controls like dimmers, timers, and motion sensors to make sure our lights are super efficient. Go for warmer colored lamps instead of those harsh blue ones. Oh, and consider using fully shielded light fixtures, like those cool vintage table lamps. They direct the light down where you need it, so you don't get that annoying glare or light scattering everywhere. Plus, when you cut down on wasted light, you're not just helping out the planet, you're also saving some cash on your electric bill. Talk about a win-win!